Myself Srijan Banerjee, Assistant Professor, Department of Electrical Engineering of Garki Memorial Institute of Technology. Today, I will discuss about difference equations of a discrete time system. It has been seen that the dynamics of a continuous time systems are described by differential equations. Similarly, the dynamics of a discrete time system is expressed by difference equations. The difference equations can be obtained by discretizing differential equations. Let we assume that the dynamics of a continuous time system is yt is equal to dx dt. So, for a small duration of del t, the differentiation can be represented as dx dt is equal to xt minus x of t minus delta t divided by delta t. If we consider that delta t is equal to capital T, then the equation can be represented as yt is equal to xt minus x of t minus capital T divided by capital T. So now if we replace the time t by k and considering that the t as the sampling time, so the above equation becomes yk is equal to xk minus x of k minus 1 divided by t, and we can write that equation as 1 by t into xk minus 1 by t into x of k minus 1. So as the kth sample is xt and k minus 1th sample is x of t minus capital T, so we can write yk is equal to b naught xk minus b1 x k minus 1, and if we take b0 is equal to b1 is equal to the 1 above equation represents the dynamics of the discrete time system. The output that depends on the current and past inputs, and it may also include past outputs. So the difference equation can be defined as an equation that shows the relationship between consecutive values of a sequence and the differences among them. They are often rearranged as a recursive formula so that a system output can be computed from the input signal and past output. So, in general, the difference equation is given by a0 yk plus a1 yk minus 1 up to an k yk minus n is equal to b0 xk plus b1 xk minus 1, so on. So there are a number of basic discrete signals which is used for analysis of discrete control systems. These signals are direct counterparts of the various test signals used in the continuous time system analysis. The order of differential equations is the difference between the largest and the smallest arguments of k appearing in the equation. So for example, a0 yk plus 1 is equal to b0 into xk plus b1 into xk minus 1. So this is the equation. For this equation the order is 2, so this is a second order equation. And if we take another equation, that is y into k plus 3 is equal to b into x k minus 1 plus c into yk, for this equation the order is 4. This is the fourth order system. So now we will discuss about how we can solve a difference equations. So that means what are the methods by which we can solve a difference equation for a discrete time system of a digital control system. So basically there are mainly three types of different methods by which we can solve the difference equations. First one, classical approach. Second, sequential procedure. And the third one is transformation method. Classical approach. In this method, the solutions can be determined by finding the complementary and particular parts of the solution. The method is very similar to that used to solve differential equations. The solution of the equation can be expressed as yk is equal to yck plus ypk. The first part yck is referred to as the complementary or homogeneous solution, and the second part ypk is referred to as particular solution. To determine yck, initially we assume that xk is equal to 0. Now we simply need to solve the homogeneous difference equation, that is a0 yk plus a1 yk minus 1 plus up to an yk minus n, that is equal to 0. To determine ypk, we need to solve the difference equation. The difference equations are summation of p is equal to 0 to n ap into yq of k minus p is equal to summation of p is equal to 0 to n bp x k minus p, and summation of p is equal to 0 to n ap y k minus p is equal to 0. The next method is sequential procedure. This method is used to find the solution of the digital control system by digital computers. Let we consider a difference equation, that is yk is equal to xk minus x of k minus 1 minus y of k minus 1 for the value of k is greater than or equals to 0. Now if we assume that xk is equal to 1 for the value for the even values of k and xk is equal to 0 for the odd values of k, so we can easily find out the value of yk by putting the different values of k. So for example, y0 is equal to 1 minus 0 minus 0. That means here if we consider that x equals to k equals to 0, then the value of xk is 1, x of k minus 1 is 0, and y of k minus 1 is also 0. Then the value of y0 will become 1. The value of y1 is minus 2. The value of y2 we can easily find out by the same manner, that is 3. The value of y3 is minus 4, and value of y4 is 5, so on. Transformation method. This method is just similar to how the Laplace transform can be used to solve a differential equations. The Z transform can be used to solve difference equations. Normally, the shifting theorem is used to get the Z transform of the difference equation. For example, if we consider a difference equation, that is 8 into f of k plus 2 minus 6 f k minus 1 plus f k is equal to 0. Now if we take the Z transformations on the both side, and if we ignore the initial conditions, then the equation will become 8z square fz minus 6z inverse fz plus fz is equal to 0. So in general, the difference equation can be expressed as by a0 yk plus a1 yk minus 1 plus up to an yk minus n. that is equal to b0 xk plus b1 xk minus 1 up to bn xk minus n. Now if we consider the z transform and ignore the initial conditions for these equations, then that equation will become a0 yz plus a1 z inverse yz plus an z to the power minus n into yz is equal to b0 xz plus b1 z inverse xz plus bn z to the power minus n into xz. So taking inverse z transformation of this above equation, the solution of the difference equation can be determined. Now I am showing you some examples of solved numericals. So here we are considering one problem, one example, that is find the solution of yk plus 3 yk minus 1 is equal to xk for the range of k is 4 to 0 by sequential procedure. And another data is given that xk is equal to 1 when the value of k is even and xk is equal to 0 when the value of k is odd, and y of minus 1 is equal to minus 1. So for this differential equation we have to find out the sequential solution within the range of 0 to 4. So for that we can easily rewrite the differential equation by yk is equal to xk minus 3 of yk minus 1. So actually we know that the general form of the differential equation is yk is equal to xk minus xk minus 1 minus yk minus 1 in this way. So we just rearrange that differential equation whatever given in the questions. So for that equations, now this equation is in form of the general equation yk is equal to xk minus 3 into yk minus 1. So in this equation if we put the value of the xk for the range of k and value of yk minus 1 and so on, then we can easily find out the solution of final yk. So for example, for the first case, if we consider that k is equal to 0, then y0 is equal to x0 minus 3y in the place of k. If we put 0, then the thing will be k minus 1 will become 3y into minus 1. So as we know that x0 is equal to 1 and y of minus 1 equals to minus 1, if we put those values, then we can find out the value of y0, that is 4. In similar way, if we want to find out the value of y1, then the equation will be y1 is equal to x1 minus 3y0. So in the place of x1, as we know that xk is equal to 0 when the value of k is odd. So as 1 is odd values, so the x1 will be 0. So we put here 0 minus 3 into y0. y0 means already we got the value of y0 is 4. So the total thing will be minus 12. In this way we can find out the value of y2, y3 and y4. As the range of k is 0 to maximum 4, so in this numericals, in this example, we are finding out the value of y4. If the range will be 0 to suppose 6, then we have to find out the value up to y6. So in this way we find out the value of y0, y1, y2, y3 and y4. So the solution of yk is 4 minus 12, 37, minus 111 and 334. Okay, now we are moving to another example. The question is, solve the following difference equation: yk plus 2 plus 5 into yk plus 1 plus 6yk is equal to 0, and the given data is y0 is equal to 0 and y1 is equal to 1. So if we move to the solutions, then yk plus 2 plus 5yk plus 1 plus 6yk is equal to 0. If we take the z transform for this equation by using time shift property, then we get z square yz minus z square y0 minus z y1 plus 5 into z yz minus z y0 plus 6yz is equal to 0. Now if we substitute the initial conditions, then we will get z square yz minus z plus 5 into z yz plus 6yz is equal to 0, or z square is equal to or z square plus 5z plus 6 into yz is equal to z, or we can write yz is equal to z divided by z square plus 5z plus 6. So in this equation, if we take the partial fraction, then we can write yz is equal to 3 divided by z plus 3 minus 2 divided by z plus 2. So if we rearrange these equations, then we can write yz is equal to 3 divided by z into z divided by z plus 3 minus 2 divided by z into z divided by z plus 2. Now if we take the inverse z transform in the both side, then we can write yk is equal to 3 into minus of 3 to the power k minus 1 minus 2 into minus 2 to the power k minus 1. So for the value of k is always greater than or equals to 0. Thank you.